This is it. It's finally here, the LTT screwdriver. And the truth is, we didn't have to make it. There are loads of perfectly good screwdrivers. But this one is the best. Everything from the convenient bit storage to the perfectly tuned sound and feel of the ratchet mechanism to the fact that it is, naturally, perfectly balanced, as all things should be, is second to none. And the handle is designed to be super comfortable whether your hands resemble catcher's mitts or you buy your gloves from the children's section. But getting it to this point was an adventure. And even with my experience in product management, a shockingly expensive adventure. I mean, how can it take 3 years and hundreds of thousands of dollars to make something so seemingly basic? I'm going to tell you. But first, I gotta start paying for this thing. With this segue to our sponsor. Of course it's got a sponsor spot. Why wouldn't it have a sponsor spot? Simple MDM. Simple MDM offers ridiculously simple Apple device management for IT. Enrolling your company's Apple devices and keeping them up to date doesn't have to be frustrating. Get 50% off your first 3 months at simplemdm.com/Linus. Rather than reinventing the wheel, the smart engineer finds the best existing wheel and then refines it. So right out of the gate, MegaPro was an obvious partner. First of all, their ratchet mechanism is fantastic and has been proven reliable in the field for over 25 years. Second, they own the patent on what I believe is literally the best bit loader available for a ratcheting screwdriver. Third, and this wasn't a requirement, but it was a huge bonus, their office is a 20-minute drive from ours, making collaboration much easier. Now, the especially smart thing to do, what MegaPro implored us to do, would have been to simply rebrand one of their existing drivers. A little bit of LTT logo there, some LTT color here, maybe some computer-specific bits, and we would have been good to go. Unfortunately, I'm a perfectionist control freak who hates making money. So instead, we embarked on our 3-year journey that would have us redesign nearly every single aspect of MegaPro's existing product. Does this look anything alike to you? I mean, they're both screwdrivers. Other than that, the answer is no. For one thing, MegaPro's ratchet works in the opposite direction that you are screwing in. And not being able to alter this would have been a complete showstopper for me. Upon hearing that it should be pretty simple to go ratchet right, screw in right, we greenlit the project. More on that later though. Next, we had to redesign the handle. To be clear, theirs is great for automotive applications where you really want to give her up near the top of the driver, but it didn't provide the finer control that I expect in a more general use driver. Also, it's a little more than I can handle if you catch my drift.
At this point, I was recruited to design a handle that feels both when you have your hand up at the top or when you have it choked up, kind of like this. I settled on a 3-lobe design for the way it just kind of naturally follows the shape of your hand, and from there, I got to do my favorite thing, rapid prototyping. My philosophy is that there's no point in trying to make something perfect the first time because you're just gonna get it wrong anyway. So for my first attempt, I basically just made up dimensions in SolidWorks and threw it at the printer. This is truly terrible, but that was kind of the point. One of the main reasons it's terrible is it's literally impossible to mass manufacture. We already knew at this stage that the final parts were going to be injection molded, basically shooting a bunch of hot plastic into a metal cavity. So there are a couple of important considerations. First, no areas can be too thin. At below about 80 thousandths of an inch, our molten plastic won't flow through the mold, and even if it did, our finished part might be easy to break. Also, no areas can be too thick, since the plastic can sag while cooling and look pretty strange. More importantly though, the two halves of the mold have to be able to come apart. So in this first version of the handle, these scalloped areas here would have resulted in the mold completely destroying our part seconds after it had been made. Not ideal. Anyway, 5 versions later, I landed on the first handle that I liked, aka the Long Boy. Unfortunately, this was one of our first major roadblocks. Linus said it was too big, and I had already made this handle as small as I possibly could without changing the MegaPro internals. To make it smaller, we'd have to get pretty creative and spend a bunch of money. One option was to decrease the length of the zinc housing that connects the shaft to the handle, but We were afraid that would decrease how much torque you can transmit through the handle. Another option was to decrease the number of bits to 6, but we felt 12 was a necessity for tech work. What we were willing to give up though was the length of the bits. By reducing them from 25mm to 20, and making a couple alterations to the zinc housing, we were able to make our handle nearly an inch shorter than Mega Pro's and create a handle that is awesome to use no matter your hand size. 2 versions later, we arrived at version 7, which is the handle design you can buy now. I did create versions 8 through 20, but all of them are worse than number 7. So 7 it is.
There was a small problem with our handle design though. How do you access the bit loader? Mega Pro has 2 little indents on the sides of the handle, but with our trilobular design, that looks and feels pretty gross. To make the whole driver feel more cohesive then, we hired Whitebox Designs in Vancouver to help us out. They came up with a bunch of different ideas, some resembling things like our water bottle and some a bit more abstract. Around this time, it was becoming pretty clear that Alex needed some help since balancing doing an engineer's full-time job with writing an LTT video a week was becoming unsustainable. So we went engineer fishing and hooked ourselves a Kyle. His first task was to perfect our end cap. We liked Whitebox's little ribbed ends, but getting it correct was difficult since too large of a rib can make using the screwdriver uncomfortable in your palm, but having them too small makes getting at the bits difficult. After 3D printing a bunch that could be interchanged quickly using magnets, we found that this one was the best. All of this work led to the 3D printed prototype in my hand. Looks strikingly similar to the finished product, doesn't it? So given that this was high fives all around done in August of 2020 with the launch scheduled for 5 months later, how on earth did it take another 2 years? Internally, we call this Kickstarter syndrome. Up until that point, every obstacle had been overcome relatively quickly, and we even had our manufacturing partner locked in. We felt basically invincible, and we were tempted to launch a pre-order campaign. But if we had done that, we would have a heck of a lot of angry customers right now because we either would have shipped a bad product or they would have waited 2 years after submitting payment. As it turns out, going from pretty much ready to mass production ready is a lot of work. To be clear, some of it was still pretty straightforward. We worked with innovative tool and die in Delta to create our plastic molds, and the process for that was, well, I wouldn't say painless, because we did have to hand them over $200,000 US, but that was basically it. We gave them the money, they gave us the molds. And I gotta say, until now, I didn't know much about plastic mold making other than that it's super expensive. But after seeing how it's done, the price tag makes a bit more sense to me. We went with hardened steel molds instead of aluminum ones because they last way longer, and our intention is that we are going to make hundreds of thousands, maybe even millions of screwdrivers before those molds finally kick the can. The problem with hardened steel molds though, is that they're made of hardened steel. They are extremely difficult to machine. To accomplish this then, Innovative Tool and Die used EDM. No, not that kind. Electrical discharge machining. We're not gonna have time to fully explain EDM here. This fantastic video by Applied Science should handle that for us nicely. But the TLDR is that they're using a carbon electrode in the shape of our screwdriver and then a bunch of electricity to slowly zap away the steel. This process has to be incredibly precise because ultimately it will determine not only the shape, but even the texture of the surface of the finished product. We chose a satin finish for our handle that looks great out of the box and wears out very evenly, which is technically called CH30 NRRAUM 320 if you're a mold turbo nerd. While the plastic molds were getting made, we also had to finalize the shaft. You might have noticed that our original designs had the knurling go all the way up to the base of the shaft, but we added this little ridge here, and the reason for that was so that we'd have as much material as possible to hold the shaft onto the ratchet. We tried a lot of different materials for shafts. These ones are aluminum, which were just too soft and felt kind of cheap. These ones are stainless steel, these ones are high carbon steel, and then we also tried like different knurlings. This one's straight, which was kind of awful for slipping between your fingers. And what we ultimately settled on was 303 stainless steel for a good mix of durability and machinability. I just want to mention here that we made sure to go fairly aggressive with the knurling, and most PC screws can be almost entirely tightened using the shaft. So you would use it kind of like this. One unfortunate thing that we learned during the testing of our prototype screwdrivers though, was that the black coating on the shaft was simply not durable enough. It wasn't for lack of trying. The 40 micrometer black chrome plating treatment was the closest we got, but even that got stripped pretty quickly, especially by sharp things like heatsink fins. So sadly, aside from some early orders where we are allowing people to buy the black one knowing that it's going to wear off, we're going to be primarily selling the screwdriver with a silver shaft so that it doesn't look terrible in a year. As a consolation though, the silver shaft is passivated by dipping it in a nitric bath to give it a nice protective oxide coating because, despite its name, stainless steel isn't actually totally stainless. So this design choice was not about saving a buck, it was about making the most durable possible product. Also in the shaft is the strongest magnet that we could get our hands on. The minimum pull force that this is rated for is 5 newtons. But from our testing, they've been anywhere between 7 to 11 newtons. And this was to address one of my personal pet peeves, where your bit gets kind of stuck on the screw and then gets left behind when you pull out. And I can confidently say that that will be an extremely rare occurrence with our driver. I've had it happen a grand total of about 5 times in the last couple of years. While we're on the topic of materials, let's give you a rundown on what the entire screwdriver is made out of. The main plastics, so the handle, the end cap, and the selector ring, are all made out of a material called Triax 1120. It's a nylon-rich ABS blend that we don't know the exact composition of. It's a trade secret. But what we do know is that it's as strong as frickin' heck and offers a great balance of chemical and abrasion resistance. The internal plastics are also mostly Triax 1120, but the bit clips and the little ninja star that's in between them, as we like to call it, are made out of Delrin for its excellent wear characteristics. The last thing you want is for these little holders to just start snapping off on you. That would be terrible. Now, if you look really closely, you can actually see a small color mismatch between the Triax and the Delrin, but we did our best with it, and I'm pretty sure that if I didn't just point it out, no one would have ever noticed. But I did point it out, because I would hate for you guys to think that it's literally perfect. Speaking of flaws, I'm going to point out another one. In the molds. I mean, first of all, we're incredibly impressed with the quality of the molds from Innovative Tool and Die. Every injection molded part is going to have parting lines where the 2 dies of the mold meet, and they are virtually undetectable on our handle. Like, props, guys. Kyle's been working as a production engineer for 10 years, and he's never seen molds this good before. But while on most of the molds, we were able to hide the gate, which is where the plastic gets injected and there's a little sprue that needs to be broken off. Like on the handle, it's right here where it's going to be hidden by the selector ring. There was one we couldn't hide, and that was on the selector ring itself. On the first batch we got, it was super obvious. Like, look at this thing. So we worked with the mold makers to change the gate location and make it as small as possible, leaving us with this little tiny blemish. Again, this is a very small flaw, but I am pointing it out to demonstrate how obsessive we were over the tiny details of this product. They really do matter. And some of them matter a lot, like the revisions that we made to the Ninja Star. Originally, between the 2 rows of bits, there was supposed to be a round plastic washer, and this was to help hold the bits in place so that they couldn't accidentally slide into another position. Unfortunately, it limited compatibility to the 20mm long bits that we sell, or to less common 16mm bits from other vendors, like this one. By this point, we were completely committed to our shorty bits though. Not only do they enable the excellent ergonomics of our handle, but it turns out that the shorter length enhances our already incredibly strong magnet, so you don't have to worry about dropping even very large ferrous screws. But then, we also didn't want to lock people into a single vendor for replacement bits, even if it's us. That sucks. I mean, our bits are great. They're black oxide coated S2 tool steel, and we're going to have a wide variety of different sets available right at launch. And furthermore, we rationalized, if you really wanted to buy your own bits, you could just angle grind 5mm off a standard one. But what we really wanted was to find some way that we could ensure that longer bits could still be accommodated. And so the Ninja Star was born. You just take a pick, turn it so that it lines up with in between the bit holders, and yeah, it'll knock down the number of bits that you can carry down to 6, but this ensures that you will always be able to find something to store in your screwdriver handle, even if you lose all of these and I die and we go out of business. Anyway, we had all of this figured out and all of the plastic molds done by the summer of 2021, hoping for a December launch. That's when things got really stupid. The zinc ratchet molds were going to be made in Taiwan by the same factory that MegaPro has been using for 20 years. And then suddenly, they started becoming less responsive. By this point, we had individually approved every component of the ratchet mechanism from the factory, and all we needed was a final assembled sample before hitting go on production. Then, this mess arrived.
It's okay, Linus, I got it from here. This is hot garbage. Imagine waiting for your final pre-production samples and then receiving a bucket of disappointment. To summarize, the shaft flops around like a wet noodle. The ratchet sounds like 3 gears short of a bad gearbox. And the knurling is basically smooth. It's like we told them what to do and they just didn't do it. And then sent us this. And it was late.
Everything about this sample was terrible. You can even just tell by the knurling on the shaft. Like this, how could these both even be from the same factory? Well, we can't get too much into that because there are some legal things that we're still figuring out, but basically, the factory that we were using was bought out by a large tool maker, and they were now prioritizing, naturally, their own tools. So long story short, we got fed up with their terrible communication and delays, not to mention their terrible quality, and we changed to a different factory in China, potentially losing our $130,000 US deposit in the process. Once we started getting in samples from the Chinese factory, we had more problems. The ratchet, which previously had been the one thing that hadn't gone wrong, started to jam. To show you why, we're gonna have to take a closer look at how our ratchet mechanism works. Press fit into the rear of the shaft is the ratchet wheel. There are then 2 pawls that engage with it. So you can see them right here. If both of them are engaged, the shaft is locked. But if you move one of them up a little bit, you can spin the shaft in one direction. To move the pawls out of the way, there are 2 pieces of Delrin that interact with the selector ring. And it turns out that this guy right here was made 5/1000th of an inch out of spec. 5/1000th of an inch! That's like the width of 2 hairs. But because it's a lever, that error was multiplied across the mechanisms, leading to our jamming issues. The bad news is that it took us over 6 months of barking up various trees to figure out that this was the problem. The good news is that in that time, we tweaked nearly every part of the mechanism to tighten up tolerances, increase reliability, and to dramatically improve the feel of the ratchet over MegaPro's already A-tier design. It not only sounds amazing, but we went out and bought all of the screwdrivers that the haters have been telling us are certainly better than their novice first attempt. And by comparison, ours has extremely low back force, making it really easy to get a screw started, and an excellent hand feel. It also happens to be strong enough for heavy automotive work with a minimum spec of 25 Newton meters for torque, although we've actually tested them up to 30 Newton meters and they still work perfectly fine. It should be noted, if you get to that point though, whatever screw that you're reefing on is probably a hollowed out circle. While we were fixing the ratchet mechanism, another thing we played around with was the tolerance of this Delrin ring that holds the shaft in place. We settled on a 5 thou gap between the sleeve and the shaft, finding that it was the best compromise between a solid shaft feel while still allowing good ratchet movement. There's a prototype here that has a tighter collar. Yes, here we go. Oh, the feel of this is not good, but that's in the past. Today is now. Now is today. You know what? Whatever, it doesn't matter. Let's go build a final one. And what better place to do it than here at PH Molds in Maple Ridge, British Columbia, where our finished driver handles are currently being produced in the machine right behind us. Let's take a closer look.
Yeah.
Whoa, this bad boy is heavy.
Yep.
It all starts here in this nondescript paper barrel full of our plastic material called triax, mixed up with these black pieces that are a dye, a pigment, that are gonna help us achieve the black color that we want for our screwdriver handle. You're gonna vacuum these up into this industrial dryer apparatus right here, and once they've got all the moisture sucked out of them, they get crapped out into this bucket that we then take. I'm gonna actually leave the bucket there. I don't know if it's just gonna dump a load into it, but it comes out of that bucket, which then gets dumped into this hopper. The plastic pellets are gravity fed into the molding machine, at which point things get a little spicier. You can actually see the piston right here that is driving molten plastic into the mold. But how does it get molten?
The pellets go into what we call the auger, which is a hollowed out cylindrical tube that has an Archimedes screw in the middle that's actually tapered outward as you go along that way. What that does is it not only melts the plastic into a molten state needed to actually inject it into the mold.
So there's a heating element.
There's a heating element for sure that brings it up to plus 250 something Celsius, and it's tapered. That helps both with mixing and creating enough pressure for the piston to actually come and grab it.
As wild as this feels right now, I have never actually seen in person the mold that
You paid for?
made.
That you paid for?
Yeah, I did have
It's
to do
that
that.
hunk of metal right there is the whole mold assembly.
Oh wow, okay.
It's the whole assembly that you actually pay for, which is why a mold cost can be actually really expensive. Unless you have like a master die, which is the outer bits, and you just pay for the plates, which is the cavity and the core, you actually have to pay for the entire assembly. So they load the entire assembly with a massive 10-ton overhead crane. So they load it in, and then they connect up all the hoses, and basically all it does is shoots, opens, ejects, closes, shoots, open, ejects, and it's on automatic right now.
Okay, so we can see it go.
You can literally like watch this thing.
Whoa!
There's a part
Hey,
right
there's
there.
a part. Oh, it's hot.
Yeah, it's hot. Get gloves. Also, somebody's screwdrivers might have Linus's fingerprints in it.
There goes another one.
What's actually cool about this mold, it has a core that goes inside here, a cavity that goes over there, and then two slides that go around the sides to form the whole part. So what a mold is it's basically a negative of what you're trying to create.
Right.
So inside, when the mold closes, there's exactly this space here, right? To actually shoot.
Und exactly.
Exactly, right? So this is called a sprue, and that's called a runner. So these are unfortunately, well, they're not lost, because what we do is we cut these off and we regrind them to add to that pellet stuff that we just got earlier on.
But you can only have so much percentage of regrind. You have to have some virgin material going in. So what are we going to get away with?
So
like 10, 20%?
It depends on the part, but for most of the outer components, it's 25%.
Got it.
So what we want to aim for is that the sprue and the runners are under 25% of the total shot.
So that way we have basically no waste.
Exactly. We don't always get it, but we try, right? This mold is unfortunately not something that we call auto ejection. So it does eject, but it doesn't automatically cut the gate. That has to be manually trimmed. Most of our other molds cut the gate away as they eject, which is a very satisfying process if you actually get to see it. Unfortunately, we don't have that mold loaded right now, so you're gonna have to take my word for it. But this is not so bad. It's a single cut. That actual part is hidden, so you'll never see it. But you know, watching this video, you get to get a sneak peek of the handle as it comes out of the machine. It's going to be about 40 seconds. That's probably about a 40-second cycle time.
Right.
You actually have to wait for the plastic to cool before you eject it. You can't just YOLO shoot. You have to wait for it to solidify a bit, and then you can push it out. But once it comes out,
that's where the coolant pipes come in, right?
yes, that's exactly. You want the mold to be hot, but not too hot. That's where the coolant comes in. There it goes. Yee. That's sick.
That's
eh?
awesome.
Yeah.
Brandon, you're gonna have to bear with me for a second here. This is a bit more of a time-sensitive operation than I initially anticipated. The first thing we gotta do is we gotta take the hot handles. That's critical because we're using a press fit to ensure that our ratchet mechanism stays in place in the handle, which means that we're taking advantage of the cooling of the handle to ensure that this stays in place. All right, we put our accent ring on, then this is keyed, so it only goes in one way. we put our ratchet assembly in place, we put these stoppers in the end of the shaft, and boom, it automatically press fits the ratchet into the handle. And then the other side that I was already working on pops out. These two go in here, and these guys get bit holders, which are also going to be press fit once I move it over here. These are finished drivers, which get put into these reusable styrofoam flats that will be forwarded to us for packaging. Now, one of the things we're looking for in QC is what they're calling gas marks, or also, while we're at it, any just random scratches on the finished part. You guys want a perfect, pristine screwdriver that I haven't dropped, right? Yeah, you do. If we allow the parts to sit in the tray behind me for too long, they cool enough that we cannot use them. So quick QC looks good. That explains why these guys weren't moving out of the way for the camera or nothing. They got screwdrivers to make. That also explains why we need gloves, because the parts that we're handling in this process are by their very nature hot. I'm still one part behind. I'm not catching up. It's almost like this is an optimized process.
Careful, don't scratch it, buddy.
Here, I'm not scratching them, Kyle.
Jeez, man.
Relax, Kyle.
People are gonna get this. Use the freaking guy! Oh my word, what are you doing? Come on, man.
I'm falling behind. I am sweating so much right now, Brandon. Like, I am pouring sweat at the moment. Ow, that one's too hot. Okay, I give up. Help me. Help. I'm waving the white flag.
Why, what's wrong? Oh, you want the operator to come back?
Yeah, they can come back.
Okay, we're done.
As you guys probably figured out, if we're in mass production, we're probably taking orders. It's gonna take us a little while to get caught up to the volume of orders we're expecting. So we're gonna have a wave system kind of like we had for Backpack, but our production capacity for these is much higher. So guys, check out the page. We're gonna have it linked down below where you can get your place in line. I could not be more excited for you guys to finally get your hands on this thing.
It's been like, what, 3 years?
Yeah. It's not really customary on our videos, but this was not a normal project. So Herman from MegaPro and actually the whole team there deserve a huge thanks here. I mean, he could have easily said, "Puh, these kids have no idea what they're getting into. They're not even tool makers," and simply stopped returning our calls. But instead, he took a personal interest in this project and made sure that it could succeed. Also, massive shout out to all of our own team, aside from the engineers, like Sarah, who designed our awesome, not to mention durable packaging, and our partners, except for that factory in Taiwan that we're still trying to get our deposit back from. Those guys can eat one if you know what I'm talking about. We absolutely love the final result though. It was worth it. We set out to build the best driver for building computers, and in doing so, ended up building something that's amazing for just about any task. So don't wait, go check it out, lttstore.com. And go check out our sponsor.
Squarespace. If you're building your brand online in 2022, you should absolutely have a website. And if you need a tool to help you build that brand, look no further than Squarespace. Squarespace is the all-in-one platform to help you expand your brand online. Make a beautiful website, engage with your audience, and sell anything and everything from products to content. We love Squarespace so much, we use it here at LMG. We're not just talking crap. We use it day to day. It's custom templates make it easy to stand out with a beautiful website that fits your needs. You can maximize your visibility thanks to a full suite of integrated SEO features, and their analytic insights help you optimize for performance so you can see what's going well and what needs a little work. So get started today and head to squarespace.com/LTT to get 10% off your first purchase.
If you guys enjoyed this video, why don't I throw to the labs video where we ran through some of what the engineers are doing over there. Isn't that wild? 3 years ago, we had 0 engineers, and now we're expanding our engineering team at kind of an alarming rate. But we're not gonna run out of money because you guys are gonna buy lots of screwdrivers.